Hello and welcome. Today we're going to be learning about sketching parabolas using the method of factorization. So essentially, before you jump into this, you need to make sure that you are really solid with all of your factorization techniques on any type of quadratic that is able to be factorized. And that includes monic trinomials such as this one here, non-monic trinomials, again using the PSF method here, any type of difference of two squares. So for example, factorizing something that might look like a square number minus a squared term, something like that. Or indeed being able to factorize anything that might be a perfect square. So for example, being able to factorize this particular quadratic. Okay, so once you have all of these methods underneath your belt for factorizing, plus the non-monics using PSF, then you'll be able to go and approach the question that we have here in purple. So diving into it, let's have a little bit of a look at what the question's actually asking, our motivating question, and we'll unpack what we need. So it says to sketch this particular quadratic, this parabola, noticing that we have y, and it's a quadratic because we have a square in the power. Okay, so it's power 2 for the leading term, showing the important features. Now, leading up to this particular lesson, we've been doing a little bit of graphing of parabolas, and we know that the important features from that in vertex form include the y-intercept, just like when we're sketching straight lines, the x-intercepts, and we can have 1, we can have 0, or we can have 2 x-intercepts, depending on the type of parabola, and I'll show you those today. Okay. And the vertex, which we know has to go through the axis of symmetry. So we'll often find that to be able to find the vertex. So once you've done all of those key skills and you know how we go and find each of those particular things, then we're able to begin sketching parabolas. Okay, so moving down a little bit, essentially what we're going to do is we're going to create a little bit of a plan to be able to sketch. Now, we will add things to this and take things out, but this is sort of our plan to begin as a foundation for sketching parabolas sort of in any form. And I always like to think about the fact that the easiest thing to find on any parabola is to find the y-intercept, and that's when x equals 0. The next easiest thing is to find the x-intercept. That's when y equals 0, and that's where our PSF is going to come in today. Okay. Providing that we need to do PSF, there are other factorizations that we can use, such as the difference of two squares. Finding the axis of symmetry, and remember, we've got a couple of different methods to be able to find the axis of symmetry. We have, for that particular point, x equals minus b on 2a, or finding the middle of the two x-intercepts. We then sub that in to find the vertex, the y value, because this will give us a x value, and then we sketch it. Remembering that if it is a positive leading term, it's happy, and if it is a negative leading term, then it is sad. So, without further ado, let's jump in and begin to sketch our parabolas. So, here's our first particular example here. You'll notice that it says to sketch our non-monic trinomial. So it also says to show all important features. So we're going to work our way through that list that we had just up there a moment ago, step by step, so that we can make sure that we don't make any mistakes. Now, okay, it doesn't take too long. The first thing that we're going to work for is we're going to work for our y-intercept. Okay, so it's really important that you communicate what you're doing in these steps, because there's a lot of moving parts and you don't want to go and make a mistake anywhere. Okay, so our y-intercept occurs when x equals 0. We're telling whoever's reading our solution what we're doing. So we're substituting in 0 wherever we see an x up in our original equation. So y is equal to 0 squared minus 2 times 0 minus 3. That's going to be our y-intercept. And you'll note that whenever we substitute in what x equals 0, and our parabola is in general form, i.e., okay, where we have ax squared plus bx plus c, okay, all together, not in any brackets, it's always going to be the number without an x, i.e. the constant term. So our y-intercept is going to be equal to minus 3. Our next step, and I'll do this in a slightly different color, is going to be our x-intercept. And that occurs when y equals 0. Okay, so we're moving to our next step now. All right, so letting y equal 0, I'm going to take this y, I'm going to make it 0, and I'm just going to switch the sides of the equation just so it's a little bit easier for you to see what we're working with. So we're actually going to have x squared minus 2x minus 3 is equal to 0. Now don't freak out. All I've done is just replace that 0, no, sorry, that y with with a 0, and I've just put it on the right hand side. I haven't done anything too crazy. So now you'll realize this is exactly what we've been practicing for the past couple of weeks. We have our monic quadratic. It's all equal to 0. So we want to go and factorize it using PSF. Okay, so two numbers that multiply together to give us -3 and add together to give us -2. And you'll notice our factors, PSF, are going to be -3 and +1. Because it's monic, we can jump straight into the shortcut of being able to write our brackets very, very quickly. And it's just going to be our factors. So it's x minus 3 x plus 1, okay? If you're not sure whether or not you've made a mistake at this particular point, you can expand those brackets out and see if you get your original quadratic back, okay? Solving it now, okay, I want to know what makes this bracket equal to 0, which is the opposite of -3, so we end up with +3. And I want to know what makes the other bracket equal to 0, so that's substituting in x equals -1. Okay, doesn't really matter which order you write them in. I tend to write them in increasing order, so -1 and +3. Okay, and that just helps make sure that I'm keeping my x-intercepts in a nice, orderly fashion. Okay, so now what we're going to do, we've gone and we've found the x-intercepts. Our next step is to go and find our axis of symmetry. Okay, so our axis of symmetry, that can be done one of two ways. You can do x equals -b on 2a, or you can find the middle of 3 and -1. Both will work. So axis of symmetry. Okay, I'll show you in method 1, and I'll do that method 1 in blue for you to be able to see. Okay, so if we find the middle of our x-intercepts, okay, so method 1, we're going to find the middle of 3 and -1, so we add them together. And then we divide by 2. 3 plus -1 is equal to +2. And then we divide by 2. We end up with our axis of symmetry being equal to x equals, we'll write x equals 1 there. Okay. If I go and look at method 2, okay, which is using the formula, okay, we can see that x is equal to -b all over 2a. Going back up here to our particular function, we notice that b equals -2, and because it's monic, a equals 1. So we're going to substitute that back in. So that is equal to minus, being careful with negatives here, -2, all over 2 times 1. Okay, oh, I've got a rubber. -2 is equal to +2, divided by 2 is also equal to 1. Okay, both ways work depending on whether or not you have nice x-intercepts. Okay, you may find method 1 really, really easy. We keep method 2 up our sleeves once we have third x-intercepts to be able to work with. Okay, and now the very final step, okay, once we found the axis symmetry, is we find the vertex. And that occurs at the point where we have our axis of symmetry. So our vertex when x equals 1. So we're substituting in x to be able to find the y value of our vertex. So y is equal to, wherever we see an x in our equation, we're going to now replace it with 1. So y is equal to 1 squared minus 2 times 1 minus 3. And that's just substituting into our equation there. After we've done all of that and we've evaluated, we should end up with -4. So our vertex, okay, is at 1 minus 4. Now, the only other thing that we have to go and check is whether or not our parabola is happy or sad. And you'll notice that the number out the front of the parabola is positive, so therefore we're going to have a concave up or a happy parabola. Okay, let's go and put all of our information in now so that way we can go and sketch. We have our y-intercept occurring at -3, Okay, so down here at -3, we have our x-intercepts occurring at -1 and at +3. Okay, I'll do my best to keep this to scale where I can on this particular graph. Okay, and then we have our vertex occurring over here at 1 and -4, so 1 and -4 there. Okay, so now all we go and do is we connect the dots. Now I'll do my best to do this on the iPad, but it is on glass, so it may not be as neat as what we want, but let's see how we go. So I've gone and very quickly sketched it just to make sure that it is neat. All right, the final thing doing that we need to include, okay, the final thing that we need to include is the coordinates of our vertex, okay? Now, it's not necessary in Year 10 on all types of graph to include coordinates of turning points, particularly if we have a cubic in factorized form, because we don't necessarily always have the vertex as an important feature. But for parabolas, we always include the two intercepts for the x, the intercept for the y, and the vertex. Okay, so that's how we go and sketch a parabola in factorized form, or to be able to use factorization to sketch it. So I'm going to do a couple more examples across the next couple of videos to show you a few variations so you can have a little bit of a play. And hopefully that helps you build some confidence. Okay, thanks very much.